Welcome everyone. Today we have our another new episode and we will discuss on what does the universe end. We have our world famous speaker, Professor Edward, Mr. Gary and Professor David Smith. World Talent Economy Forum, we are heavily involved with emerging economy. Definitely we are getting a lot of support, specifically knowledge-oriented support from developed world through this dialogue, through research and innovations. And you will be happy. World Talent Economy Forum collaborate with Bida. It's actually run by Prime Minister Office of Bangladesh. They encourage more innovation, more research, and we are integrated with economic zones and definitely different master plan of emerging economy through Central Bank of Bangladesh. So hopefully our dialogues will be more effective when we integrated with this kind of projects. We have a plan to develop 300 cities around Asia Pacific. So hopefully all of your dialogue come up with a different idea, come up with a different action. So we believe in action. Let's start our dialogue. Professor Edward, what you want to share with our audience?
Well, the topic is, where does the universe end? And in one sense, the answer is very simple. We don't know, because the way the question is formed, where is kind of a very slippery concept when you talk about the universe. And for your listeners, I'll give you a few basics and then we can go from there. From what we know from all the evidence and science, the universe, that what we call the universe, the cosmos, started about 13.7 billion years ago, something along those lines. But here's the problem. When you talk about where, it makes no sense in this context. When we think of the Big Bang, when the universe came into being, we think of something exploding into space. But that's not the case, because there was no space in which it could explode. Okay, space itself, space-time itself was in a sense emerging into what? Well, again, the question doesn't really make sense to us because of the way our minds are fastened and fashioned. So when you say where does it end? In one sense, there's always been a debate about whether the universe is physically eternal or whether it's bounded or limited. And one bit of evidence that your listeners can try and for themselves is so-called Obert's paradox. If you walk out at night, you look at the night sky, what do you see in a clear night? Well, you see stars and then you see a lot of darkness, right? And the reason you see a lot of darkness is because the universe is, at least in time, finite. If it weren't, then every bit of space, as you go out, would be occupied by something, and the sky would be glowing, but it's not glowing. So we kind of have some evidence that it's finite. But the problem is this: when you talk about space, and where does it end? Think about this. Most people who might think this way, they might think, well, at some point you reach the edge, and then, well, what is over the edge? For example, I'm in a room, and I can talk about the boundaries of this room, and I can say, where does this room end? My room ends right there on that wall, and the ceiling and the floor. That's where my room ends. But you can't talk about the universe like that. Or the cosmos is a better word, frankly, than the universe, because you kind of think, well, if I come right up to the edge of the universe, can I throw a rock over it? It makes no sense, because our minds cannot comprehend things in these dimensions. One interesting heuristic way of thinking about it is this. Okay, here we have a sphere. Sorry, very loud one. This happens to be a globe, but you don't have to. You can ignore the maps of the world on here. Bangladesh is right over there, by the way, over there. Okay, think of it like this. What if you are a two-dimensional creature? Okay, you can move this way and this way, but you can't move this way. All you know is this. Okay, so if you are a two-dimensional creature on this universe, where does this end? Well, in a sense, it doesn't. You can go all the way around here. You can go around. You can always come back to the start. So it's bounded, but it's not. But in a sense, you can never find its edge or its end, right? If you're thinking of you're a two-dimensional creature on a three-dimensional globe like this, you have to think of it that way. This is something the human mind finds it almost impossible to comprehend. One thing I would suggest for your readers, if they're really interested in getting into this subject, there are a lot of really good books. One of the famous ones is Stephen Hawking's A Brief History of Time. Hawking, of course, was one of the great physicists of our time, and I highly recommend that book. He tries to explain in a simpler way these concepts. Universe in a Nutshell is another one of his books, but there's a lot of other fine books out there about this. But so the answer is, where does the universe end? In one sense, the question doesn't make sense given the way the universe came into being. It didn't explode into space. Space-time itself came out. And we don't know, by the way, whether it's going to be expanding forever or whether it's going to contract again into a big crunch and then come again. And we don't even know whether there are extra dimensions at the quantum level. String theory, for example, suggests this, that would completely change our view of what space-time actually is. So with those mind-blowing and mind-expanding thoughts, I will leave it to my esteemed colleagues here to take up the discussion and hopefully enlighten your audience. I myself have to go enlighten my twins right now. We might try to go to a museum today, so maybe they'll look at the space stuff at the Air and Space Museum down here in Washington, D.C. So anyway, Happy New Year, everybody.
Happy New Year. Thank you. Thank you, Professor Edward. Mr. Gary, what you want to add for today's discussion?
Thank you, sir. Well, one of the things that I looked at was what's the definition of universe? Universe is basically everything. You know, it's you, it's me, it's our life, it's what we live. It's going, you know, it goes on forever and ever. So one of the things that I have always thought about with the universe is, yes, what is out there, as in the universe, as in space, and going that way. You know, does it end? Does it ever end? Will it ever end? You know, is it one universe? Is it other universes? But then under the definition of universe, everything is in that one thing. So what other galaxies are there? Is there other living life out there? That's questions that I have always asked and I've always wondered. And I would love to know. But the universe is so vast. As Doctor said, that it's we can't fathom it. Our minds, we just can't go that far. It's just, you know, I have a saying, you don't know what you don't know. So I think the universe, where does it end? I don't think we can go there and think of that. But then you have another definition of universe. Where does it end? And it's your personal universe. You know, where does your personal universe end? Me, I've tried to be universal, so to say. I've traveled the world. I've visited and worked over 30 countries, and my universe is a lot vaster than 95% of the people in the world, I believe, because most people don't even leave their own city, their own town, and for them, that's their universe. You know, their universe is in comparison to us or to other people that have traveled, that have worked around the world, that have seen other countries, other ways people live. Our universes are a lot bigger and a lot. To me, I've enjoyed the travel. I enjoy going out and seeing how other people live. I love living in other countries where you're not a tourist and you can see. So for me, my universe, I think, is a lot vaster than a lot of people's because I've experienced it. Not because I'm smarter, not because I'm better, not because I'm worse, not because I'm taller, whatever. Just because I've done it. I've been there, done that. So for me, my universe, I think is massive. I think is a very interesting universe. I'm always wanting to grow my universe, and I don't think I'll ever grow. Well, don't think. You'll never grow as big as the universe of stars and galaxies and things like that. And I know in my lifetime, I'll never know the answer to that. And I think that's something that we need to, we keep going after, we keep looking for it, we keep chasing it, we keep sending rockets, we keep sending different NASA things out there. And I think we get further and further and further, and we find out more and more and more what's out there. So where does the universe end? I don't think it has an end. I agree. I think it goes on and on and on.
Thank you, Professor David Smith. Professor David Smith.
Thank you so much. It took a minute to get down to mute there. You know, one of the things that when we think about where does the universe really end is that we're viewing that question in view of our human perception. And that really everything you see depends on light bouncing off objects. And many scientists don't believe there's a true edge of the universe, but there's an end or an edge to the universe to what humans can see. And in scientific terms, this is just called the edge of the observable universe. And it's really where we can go see. But let's understand one other principle here is that when we try to look at the universe from our perspective here on the Earth, we're always looking in the past. It's because light has to travel a long time before it reaches our eyes. And the further and further away it is from the Earth, the longer it takes. And, even our nearest bright light source, the sun, it takes 8 minutes to get from the sun to here. From our nearest star, it takes about 4 years. So it really helps us get really out there. Scientists are telling us the furthest edge of the observable universe is about 3.8 billion years in the past. And so it's really a big question that we're talking about here, and where we're headed to in the future. And one fact to remember though when we start talking about the edge is many people say that the universe is infinite. But on the other hand, we tend to see our universe as finite. So once the sun expends all its hydrogen, it'll turn into a giant red star and will grow so big it will reach the Earth and beyond. And so we see that really coming here and how we deal with it. So we really have to go and understand that we have to understand our space-time continuum, putting Einstein view, or a discontinuum as most of us look at it. We know that we see the universe is still expanding. And if it's expanding, which is called the Big Rip theory, we think it's going to expand forever. In that we cannot even see the end of the universe. It's the end of the universe as we can really take it there. There's quite a bit of an unobserved universe too that we're beginning to see with new spacecraft and new telescopes and other things, new imaging areas. We're seeing it expanding further and further out. And how can we do that? And we as humans have a hard time dealing with the notion of nothingness. And it's hard for us to wrap our heads around infinity. So as we look at if the universe ends, it's hard for us to begin to do it. But what I'm seeing more and more is when I've asked this question by some kids sometime, I like to compare our view of the universe to a rubber band. And if we look at a rubber band, it really has no beginning, no end. It continues to stretch as we want it to stretch it. Even as we take and twist the rubber band, it's clearly we can't see a beginning or an end of a rubber band. And that's, to me, is a great way to view the universe. It's like that big rubber band that we can take and still expand and expand, but we really don't know where it starts and ends. And so that's, Sharif, were my initial thoughts.
Thank you. Professor Donald, what do you want to add? And how are you today?
Well, I feel pretty fine. For everyone that doesn't know, on Christmas Day I was taking one of my I take these run walks that are 10 or 12 miles, and I was almost home and crossing in a crosswalk, and this person just made a left turn right into me in the middle of the crosswalk, and I'm on crutches now for probably 2 months, but that was kind of disturbing. But fortunately, it could have been a lot worse. So I mean, I'm going to have powerful arms and very powerful arms. So anyway, I really appreciate what everybody said. They've all put in, different pieces of what's important. I think I like what Gary pointed out about the universe being kind of what we make it in a way that what the universe means is what it means to us. And that universe is more than just the physical universe, but the universe that, since it's all our imagination in a way. I mean, we can't see any of these stars. We see stuff on telescopes that we look at and we go, well, because this is happening and this is happening, this must be a black hole. But, it's still really kind of our imagination. And so the universe is, to a large degree, a creation of our own minds. And that fits in really well with what Edward said, which is the point of the idea that even the idea of beginnings and ends have lots to do with our own cognitive machinery. And the idea of cause and effect and beginning and ends and things like that have a lot to do with how human beings have to organize the world, or have evolved to organize the world in ways that works for them. The philosopher Kant had this idea that we couldn't really observe reality but what happened is that we had these filters built into our brain that caused us to have a sense of up and down and lines. And strangely, it was a little bit accurate in some of those kinds of things. And he called those a priori filters, so that we took whatever was out there and organized it in ways that worked for human beings. So when we start looking at the universe, we have to realize that we're looking at it with assumptions that are there for our own survival. So another thing that's really interesting to think about is something that David brought up, is that when we look out at the universe itself, what's happening is that we're looking at light that's been coming to us over a period of time. And there's a hard and fast law in the universe that nothing can go faster than the speed of light, which is about 186,000 miles per second. And so these things are so far away, we talk of them in terms of light years. So you think of how many seconds there are in a year, multiply that by 186,000, and then multiply that by 10 million, and all of a sudden you're looking at very, very long distances. And so what happens is that things that are farther and farther and farther away from us, the light has taken longer and longer and longer to get to us. So we can, in a sense, look back in the past. And one of the theories, the most believed theory, or the theory that explains the most with the best explanatory theory, is the Big Bang. And in the idea of the Big Bang, there was basically a point of just incredible energy that just exploded, basically. And that energy, as you know, E equals MC squared. Energy and mass are interchangeable. So what wound up happening is that energy started turning into mass. And first it made protons, and then it started making electrons, and then started making neutrons, and eventually started making atoms, and so on like that, and then started making eventually stars, and started making the universe. And it's been going out in all directions from that point ever since. So when you think about it, that would sort of imply that there is an edge to it. It's the edge of where that is happening. But that has a lot to do with our kind of understanding of it, because we don't, that's in a way we have to make metaphors to be able to understand things. So we have a metaphorical view of it. And that view works with our, what we see. We see that some stars are coming towards us, and some are coming away from us, and we can see that there's a place that's sort of the middle, or what that seems like, but we also know it isn't really. It's a complicated thing to say, but when we look towards that sort of middle, we can actually see back about 13.5 billion years with the James Webb Telescope. And when we get back that far, when we get back much farther than that, what winds up happening is that since stars and galaxies and things haven't been created yet, all we see is basically fog. And we get to a point where it's all fog. In fact, we're actually surprised at how well organized the universe is as far back as we're seeing. It's better organized than we thought it would be. So, those are, but where I'm going with this is that the only things that we can see are things that the light from them has reached us. So what we have, our view of the universe is only this teeny piece of the universe that the light has reached us. So maybe if you imagine the other side of the Big Bang, other side of the universe, we can't see that, but we can see that the universe is expanding, and we don't know why, but we know that we believe that there's enough energy in the universe that it's going to keep expanding. And so that sort of implies that there's an edge. But what we really think now is what Edward said, is that if you could somehow go faster than light and zip out towards the edge of the universe far enough, you'd wind up right back where you started, just like if you were on a. Have you ever done this where you've taken a strip of paper? This is really a fun thing to do. And you just take a flat strip of paper, and then you bend it so that you made it so that, like, instead of putting the two edges together like this, you flip it around and tape it together like that. And it's really a fun thing to do. That's called a Mobius strip. And then if you put a pen on it and you start drawing, and you keep drawing on this strip, and you keep drawing and drawing and drawing, you'll come back right where you started. You've made a strip that only has one side. You can do that. So in a way, the universe is like a Mobius strip. It's like it only has one side, and but it's not in 2 dimensions, it's in 4 dimensions, and so that's why that works out. So there's a book that is just really, really, really wonderful called Before the Big Bang, and it's kind of unfortunately named because it's actually about the Big Bang and what happens from the initial energy and how each of the different particles are created, and blah, all the way, and explanation of how the universe was formed. And in the last chapter, he speculates a bit on what's before the Big Bang, and there's also the idea of the multiverse, which is the idea that there could be many universes like ours, but we have no way of getting from one to the other. So that would be another thing about, well, universe. Well, maybe there's lots of universes. So that's another thing about that too. So it's not something we really know, but if you really want to get into it, the mathematics that you need to learn is topology, and and cosmology. But the mathematics itself is topology, and it's very, very interesting. It's useful for quantum physics too, and so. But I really recommend Before the Big Bang. It's a great book.
Thank you. Mr. Gary. Can you unmute, please?
Okay. So I agree with just like we've talked about, but the universe, I just wonder, is there other universes out there? I agree with you, Donald. We just don't know though. So it's one of those kind of things that you can think about it, I think, until you die. And it's, I don't know if it would be a waste thought, because I don't think us guys will never figure it out in our lifetime. So I kind of leave that off to NASA and let them figure it out. And as soon as they find something new, I keep my ears open. I love hearing when we find new planets and new galaxies and all that. It's really, it's just great to hear that. So my universe, I'm happy with mine right now. I continue growing it, and I look forward, and I hope something in our lifetime would send us out there and let us know that there's something else out there, and we can die when there was other ones and not just us. But that's about all I have to say about the universe.
Thank you. Professor David Smith.
Sharif, this question you posed to me is really a great one, because there's no right answer, there's no wrong answer. So what you're getting is us explaining that there's a whole range of possibilities for this one. And it depends on our view of science, it depends on our worldview, it depends on our levels of education, our other beliefs. So it's one that fits really well, I think, as we try to look at answers. I tend to like the answer that if we begin to start going out on the galaxies and we travel, and I agree with Donald, theoretically, the speed of light is the maximum here. But if I could break the rules of physics and travel faster than the speed of light, I would like to see where we go. I personally believe the further and further as we go out into the galaxy, we would discover new things at the end of it. And that we would just keep passing through new galaxies in every direction forever. And it would be infinite with no end. On the other hand, there's some scientists, and some I've talked to recently, who think it's possible that the universe might eventually wrap back around on itself. So that if you were just to keep going, like in my example, you would someday come back to where you started from another direction. Another way to think about the universe is it's like a big globe, and that you can only move in one direction at a time, and though it's bigger than you can imagine. But in all these cases, you would most likely never get to the end of the universe, and you would just keep going and seeing those possibilities. And that's, to me, some of the questions. It's one that we don't have the tools to answer today. That we actually, even with our understandings of space, our understanding of physics, our understanding of the space-time continuum, and others, that we don't have the adequate tools to answer this one with any degree of certainty. And that's kind of where I am with this. I would love to work to develop further science on this, but the science in this would have to be matched with observation. And we're already pushing the limits of some of our science today with getting communications coming back cleanly from outside our own galaxy, much less ones that are to get to our closest galaxy, many, many light years away. So we would have to begin to understand how to do that. But I like to think that it will continue. We know, as I said at the top, our galaxy has our solar system here, our galaxy here is a finite life cycle. We know from what we can observe around us that eventually our sun will become a big red sun, and it will grow and expand beyond where the Earth is today, and of course consume the Earth. But the universe will still continue to go on. And luckily, with our observation, we've been able to see part of this cycle of life across the universe and know partially of where we're headed and what's going to happen. But Dr. Sharif, I just really think that we don't have the tools yet to understand does the universe end. And I think based on our observation today, it probably is an infinite universe and will continue to expand just like our universe today is expanding every day. So Dr. Sharif, thank you so much.
Thank you, Professor Donald.
Well, there's a view that I don't know exactly what I would mean if I said it was infinite, because as I said, like if it's a Mobius strip that goes back on itself, it doesn't. The topology is, I mean, if it just goes back on itself, it's just one dimension. It's, I don't know how to say that. I mean, there's a theory that like you've got this center, it started at the center, it blew up from the center and it's going out like this. And out here, the galaxies are farther apart and thinner, and as it expands and expands, it's getting thinner and thinner out here. And then the theory is that as time goes on, all the galaxies and everything are going to get farther and farther apart, and all of the suns are eventually going to go out, and then eventually it's just going to be this big dead thing. But that's a long time from now. As we have to worry a lot more about the sun blowing up. I mean, that's going to happen in just a billion years. I like some of the other theories of the universe. You know, that we're on the back of a turtle, and that there's a cap over it. That stars are really these little holes going, and that's the light from heaven. And of course it's infinite because heaven's infinite, you know, God's infinite. So I mean that's one view of it. Of course, somebody asked William James made the question, and he says, well, you know, what does the turtle sit on? And one little old lady in his audience said, well, it's turtles all the way down. But there's a lot of good theories of the universe, and I guess it goes to what Gary says, is you wind up with a lot of universes if you travel and get into other people's worlds and start making your universe, because in the end, what David said is so true, is we're not going to really be able to know these things. If there are other universes, we don't have any way of knowing how to get to them, and we'll never go. I can't I don't think we're ever going to get faster than the speed of light. We're not going to, Star Trek's not going to happen. We're not going to zip around to other galaxies. So it's something that we're never really going to know. But I think a more interesting question to me is like, why do I need to know? I mean, what is it about me that makes me have to perceive things in a way that I have that question? And I think that can teach me a lot about how my perception works and how my assumptions work about life, about the universe, or about just everything, day-to-day life, and start learning to question my own assumptions. And once I start doing that, it expands my ability to be able to relate to things that are really different than my own preconceptions. And so I think asking the question is good, is useful. You can't expect to have an answer to it, but looking at the question itself and what assumptions you have to ask to answer the question is very useful. And I really appreciate both what David and Gary were saying. As David was pointing out that it's not something that we can really answer, and Gary was pointing out that the answer in a way lies within understanding your own place, your own assumptions about the universe, and that the universe is really where your assumptions about it, and that you can change and grow your assumptions. I've been to 24 countries, so I know what Gary's saying. I mean, I've lived in other countries. I know what he's saying. So it's a very cosmic topic.
Mr. Gary, what's your concluding remarks for today's session?
Okay, so I think that like Donald says, it's a good question that really doesn't have an answer because we'll never know. So no matter what answer you give, that you'll never be able to, to get the answer and see if it's real or not or whatever. It's always going to be an assumption and a hypothesis of where it is. I appreciate all the different, I love hearing the different ideas and different ways and different things that we've come up with and said. And it to me, it's broadened my mind on things. I like the analogy of the paper turned around and how you always come back to the beginning. So, the old infinite sign is an 8 on the side. So that's kind of like your rubber band scenario where, yes, it never has a beginning and never has an end. So is that the universe? If the word universe represents everything, which is what the definition says, then maybe, Donald, by your saying that there's other universes possibly out there and everything. So even the word universe is antiquated at this point, because who knows? It might be, we might have other universes and everything out there. So even, so we need to make a new word that encompasses universes, but it's a great thing to look at. And the next time I'm out where I'm away from the lights and everything, and if nobody's done this before, you need to go somewhere where there's no lights, there's nothing like total darkness, and look up, and you'll see how vast and how huge the universe is. And until you do that, I've been around cities where the lights are out 24 out and 24 on. So you're out in the middle of nowhere with a total darkness. I was in Ukraine, total darkness, total blackness. And you look up above and you look and you realize what a Milky Way is. You understand why it's called the Milky Way. You look up, there's so many stars. And that's just where you're looking up from. That's not counting what's behind you, what's on the side of you, what's below you, what's above you. That's only looking in that direction. So the universe is so vast and so beautiful. And I just hope in our lifetime we do find something else out there. And thank you, Dr. Sharif, for this. I really appreciate you inviting me here. I've enjoyed this forum.
Thank you. Thank you. Professor David Smith, what's your...
Dr. Sharif, as the other folks have said, thank you for letting us be part of this. It's great topics, and like we said, there's no right or wrong answer. So everyone by default are experts on the show today. So thank you for letting me be one of those experts. I love questions like this. Like I said before, it to me positions us to understand that we have endless possibilities, and the endless possibilities relate actually to almost every program you do, Dr. Sharif, that we can see how the developing nations are working together to move forward on things like this, how government, how commercial sector, entrepreneurs, and academia have to come together to answer this. And it's clear to see a question like this is not just a science answer. It's a philosophy answer, and it's all the other philosophical answer and all the other elements brought together with it. So to me, these are the things that help us go forward and be successful. So thank you so much for letting me be part of this, and great topic as we begin to transition to the new year. So thank you so very, very much.
Thank you, Professor David Smith. Professor Donald, what's your concluding remarks?
Well, I really want to echo what Gary and David have said, is that it's not a question that we really have an answer to, but we really don't have answers to anything, really. I mean, if you're really a scientist, you start, the more you know, the more you know you don't know. It's an old saying, but it's actually true. And I get to enter, I sort of take the attitude that when anybody says something, I always don't believe it just right off the bat, just because that allows me to start checking and learning things and trying to find out why I would believe it. I recommend everybody take that tact. It's a good one, and it's the sign, in a way, the soul of a real scientist. But I think it's exciting. One of the things that's really interesting is the relationship between quantum physics and cosmology. And that thing that I was saying about the Big Bang, about how energy is first converted into matter, and the beginning of matter, and how the universe began, or at least we believe the universe began. And we have good evidence. I mean, the James Webb telescope is showing, we guess these things, we predict these things, and then we actually can look, and lo and behold, it's just what we thought. And that's really cool. And so, maybe we're a little off here and a little off there, but it's, in general, it's pretty cool. And just knowing that a little bit about what they're looking for makes it even more exciting when you see the results of what the James Webb telescope is coming up with. You're going, oh yeah, I see, I understand why they're so excited by that. Wow. And so again, I cannot recommend the book Before the Big Bang too highly. It's for lay people. It doesn't have a lot of math in it or anything else like that. It explains things very clearly. It's a science book for regular people that you can read. And in fact, I think I'm going to reread it because it's so excellent. And that'll give you some sense of what scientists think the universe is, or cosmologists think the universe is, and then remember that the universe, no matter what it is, it's only what we can see and what we think it is. And that's all it's ever going to be. So make sure your universe is as big as it can possibly be. Thank you.
Thank you everyone for joining today's session. This is excellent discussion. Especially I want to give thanks all of our speakers, Mr. Gary, Professor David Smith, Professor Donalds, and Professor Edward. I want to give thanks to our audience who continuously support World Talent Economy Forum. Before end this universe, we want to take more action. We want to go for more progressions. And we want to minimize the gap in between developed world and developing world. Definitely with the developed worlds, we can bring more progressions in emerging economy. That is the objective of World Talent Economy Forums. Those who want to take action, join in our team and work together. Thank you. Bye-bye and take care.
Bye.